everybody, this is assignment number 5. Assignment number 5 works with abstract and interfaces, and abstraction as abstract classes. So this is the topic we're getting into. I'm going to start it today. We're going to finish it next time. It is due next time. It is not due today. The only thing that was due today, I think, was assignment number 3 and number 2. But in any case, let me preview this one. This one we're actually going to write, unlike the GUI one that we just you're going to play around with, and you're going to turn in something that you're going to assemble out of code examples, hopefully. So in assignment number 5, the employer wants to write some classes for their personnel record system to make it simpler. So we're going to consider these 4 classes. We have a person, an employee, a student, and an instructor. So this is going to be like an HR system. And the following picture is going to illustrate what the system is going to look like. So we're working with inheritance, and we're going to work with this abstract concept. The person in the parent class of the employee and the student, and the employee class is the parent class of the instructor class. So here's person on the top, and person is going to be abstract because we don't know what's going to happen with the person. We could make a lower class, and the idea is the lower you are in the hierarchy, or the closer you are to object, the more abstract you are. And so you become more specialized through the inheritance process. So a person could have like a name and an age, and then an employee is also going to be a person, but a student and an employee are going to be significantly different in this example. And then an instructor is going to be a type of employee, not really a student, so they're going to be different as well. So what we're going to do is sort of take abstraction to the next level. Very similar to the dinosaurs, but we didn't do any abstract classes in the dinosaur because all the dinos, we were actually able to make copies of dinos or instances of dino. So in here, your task is to create the appropriate fields for each one of the classes, and then necessary fields is listed below, which I'm going to go through. Add your own fields if needed, so you can specialize it. Some fields need to have appropriate constraints associated with them. For example, your age can't be negative, something like that. I don't know. Your own way, use your own way to make sure that the constraints are satisfied. Well, we can put those into the setters and the getters and stuff. So the person is going to have an ID and a name, and the employee is going to have a salary. The student is going to have a teacher ID, and it's going to have a teacher name. So what we're going to do now is we're going to assign out in main students to teachers. So not only are we going to build a hierarchy that is built on abstraction, but we're going to mix and mingle objects back and forth with each other as well. So the students, right now we've seen objects, kind of come to life and be instantiated as objects of their own and just kind of live in their own little world. Now we're going to have them communicate more with each other, and a teacher will keep track of students, and the students will keep track of their teachers, and we can put them in arrays, and we can actually just accumulate them and find out how many students does the teacher have and how many classes is the student taking, stuff like that. So we're probably not going to get to that until next time, but we'll build the foundation today, and then I'll archive it or keep it, and then we'll continue it next time. The instructor is going to have a student ID array, and it's going to be an integer array, and the array of it's going to keep track of student IDs, so student ID of the instructor. So the above fields are going to only be accessible through the access methods, which means they're going to be private, and we're going to have public member functions to change the private data, and then we're going to have a toString method. Well, we've already seen that already. To print out something about the information associated with the objects, maybe the object person's name or something. Then out in main, we're going to have a static find students method. So remember the static method we created in assignment number 3 that actually did some stuff for our menu options. We're going to do the same thing again, so we're going to see a little bit more about static stuff. And I'm probably not going to do that until next time. And then the person should be declared as an abstract class. So that's the key right here. This is the new part we're going to take a look at in a few minutes here. And then we're going to have provide multiple constructors and methods needed. Write a test program to test, or driver program to test everything. And If a class can use the parent class method and constructor, then use super. So we're going to look at how we're going to call through the inheritance hierarchy, which we haven't really done yet. We didn't do it with the dinosaurs. I call the superclass constructors and pass information back and forth between the hierarchy, between the levels of the hierarchy. Okay, so your driver program is going to be test, create some sample output, some input, stuff like that. Note the sample output is not the unique output format of the test program. It's just going to be whatever you're going to print out on the toString method. There's no main method in the 4 classes. The 4 classes are going to be objects that we're going to create. And read the description on test.java very carefully for better understanding. We have the main program is given to you. So here's the test program. So what we're also going to do here, not yet, we'll bring in the test program when we get this all built, is kind of work with some pre-written code and write the code that mixes in with it. Because what's going to end up happening out in the real world is that if you actually get into Java development, you're not going to be working by yourself. You'll probably be working with a team of developers. Somebody might be working on the person object, somebody else might be working on the student object, somebody else is writing the main program. So you're going to have to be able to read code as well as write code and work with other people's code. So it's kind of an exercise in that as well. So I'm going to save this one because we're probably not going to get to it today. We're going to finish this. We're going to start it today. We're going to finish it next time. So main, we're probably not going to write main today. I do want to hit the person class though. I want to write the person and then get to some of the other classes in the hierarchy. So I'm going to go back to Eclipse. And oh, it looks like I shut it down. Let me open it back up. Oh, let's see. Actually, I can actually get rid of this stuff. I'm going to get rid of my I'm going to make this so I can easily remember it in 2 weeks. If I delete what I'm doing right now, you probably don't want to do because you're going to want to go home and work on this stuff later. I'm deleting the project contents on the disk. I'm taking it out of my workspace folder. I'm actually going to do the same here as well because I have it all archived and it's all on the internet. So I'm just making my system easier for me to navigate. If you do this, you're going to lose your stuff. But I don't care about my stuff. I'm already done with that. So I'm going to go to, now that I'm all cleaned up, I'm going to go to File, New, Java Projects, and this one's going to be called Assignment 5. Assignment number 5. And that looks pretty good. Click on Finish. Here we are. Get the source code folder. Not very much to look at. So I'm going to go File, New, and I'm going to create a class. And the first class I want to create is Person. Person is going to be the abstract class, and I'm going to show you a little trick here with the menu. You don't have to use the menus for this, but I want to show you the menus just like I did on the constructors to kind of show you how things get automated. If I press class, I can type in the name of the class that's going to be called Person, and there's a little button here that says abstract. So click that little button there. It's going to be public. It's not, okay, so the modifiers, well, hopefully you got this from the midterm. Public is open to everybody. It is a public opening. Private is only to classes inside of the class. Protected is to classes in the hierarchy. You don't have very much in terms of the main class itself. It's usually always public. If it's package, it means it's going inside of something else, which at this point we don't have a package, so it wouldn't make any sense. And I'll talk about packages next time. I have a couple more topics I need to cover with classes and hierarchies. It's not, I'm going to leave final for the future as well. But right now we're looking at this abstract concept. So we're still coming from superclass. We don't need a public static void main in here. We don't need to do constructors or anything either. So I'm just going to press finish and I'm going to see what I get. I get something that's very similar to the other classes I have created, except for now I have this keyword abstract. An abstract class doesn't exist. Or does it exist? No, it doesn't exist. It's abstract. You can't make an instance of an abstract class. It's meant to be built on. So an abstract class has one or more abstract methods inside of it, and it has other methods as well. So I'm gonna stick in some data, and then I'm gonna put in some constructors, and I'm gonna build the class just like I would do any other person class. In fact, if I wanted to, I could actually remove the word abstract, and I would get a class just like any other class. So I'm going to play around with this concept for a few minutes because this is supposed to be a learning exercise. I believe, let me just go back real quick here. I think I had a name. Let me go back to here. Person's got an ID that's an integer and a name that's a string. So I'm going to go public, or no, private, string, name, and private integer ID. So I got some data in there. And now that I have two data items, and this is review as well, I'm going to automate this a little bit, make some constructors out of this, and do some setters and some getters. So I can do it myself, or I can go to source file, generate. I have to do the constructors first. Constructors using the fields. I want to do constructors for the name and the ID. So I'm going to press OK. Now I have a constructor that uses the name and the ID. And now I'm going to use one that doesn't do anything. So I'm going to source constructor using fields, and I'm going to unselect both. I just want to do a default constructor. Actually, here's where you're getting your protected and your private as well. So I'll label this one because I want to make sure you guys remember what this stuff is. This is a default constructor. And this one here is a constructor that does everything. Sets everything. There we go. So if it's a default constructor, then I can say that this.name is going to be equal to unknown. So I have it assigned to something. And this.id is going to be equal to, I don't know, 0. There we go. And hopefully this isn't confusing you at this point. You know what that this is, and you know what the name. This is the name here. This is the ID here. And we're just going to set some default stuff. And then this is what we did last time as well. We wrote this code in here. This is interesting. It didn't do this. It just did ID. Interesting. That was done automatically by the system. We'll just leave it alone. Now, there's nothing really too abstract about this. This is pretty, I can do setters and getters. Let's do some setters and getters. So far, we're looking like a regular old class. I'm going to go back to source and do my setters and getters. Or getters and setters. I'm going to click on both of them up here. It says select setters and getters to create. And then I'm going to press on OK. So now I have a get name, a set name, get ID, set ID. Interesting convention it used. Okay. So, different, but okay, good. Hopefully I haven't lost anyone so far. We've done this already about 3 or 4 times. Oh, this is the 5th time, or 4th time, yeah? Interesting question. Instead of this, yeah, I don't know. Interesting. I don't know why the automated system did it for me. Again, maybe it's a convention or something. I don't know. Usually ID, we're going to do this next week, but usually ID would be an auto-generated number, an integer number that we could do at the class level using a static data member, and we could put a counter on there. So every person, which is what we're going to end up doing, but every person is going to be incremented by 1. Oh, that's another good question. I don't know. The automated system did that. Again, the compiler, Eclipse decided it was going to use a small ID. I don't know. You could have made it, you mean like this? I probably could have done this. Yeah. That would work too. It's just arbitrary, I guess. Maybe there's I don't know, naming convention I like to use. Yeah, the data member itself that we have inside of the class is uppercase. So generally what ends up happening if you're going to take in from a parameter line, this has to be different. Yeah, it has to be different. Upper and lower, it's case sensitive, so upper and lower case makes it different. But the same token, if we do this, it sort of makes it the same. But if I did ID is equal to ID, it's not going to know which ID I'm talking about. But this ID, you want to make it different than the ID that you're taking in on the parameter line. So we have setters and getters, and we have constructors, and for all intents and purposes, we have a person. So I'm gonna bring out now and create a main program. We're gonna eventually use the other driver program, but I want to add something in here because I want to play around with person. So I'm gonna go File, New, Class, and I'm gonna call this one Main with a capital M. It's not abstract, but I want to click down here where it says Public Static Void Main. So I'm clicking down here on the bottom to add in the public static void main class. And then I'm clicking on Finish. And so I'm going to go back to person and I want to demonstrate something for you. So if I go back to person, I take the abstract word out of there. So I've taken abstract out. Now it just says public class person. And I'm going to save this. This is just an ordinary class, just like the dinosaur class. So in main, I can say person. I'm going to make an instance of this object now. I'm going to say that person newbie is equal to new person. Okay, and that's new person. Let's see. I know it's not spelled right. Huh. Oh, is it? What does it mean in Chinese? It's a bad word? Oh, here, I'll go here. B? Is that bad too? Or no, is it supposed to be like this? New B? No B? New V? How about new V? It's what? Newbie. Seriously? In America, it means idiot. Like noob. Have you guys heard of this? No, not idiot, but like noob. Alright, new noob. Person noob is equal to new person. Okay, and then now we can go system out. Print line. I'll just put the person's name on here. Noob dot get name. Get name. Well, their name is going to be unknown. We know that part. So if we run it now, it's just going to say unknown to the screen. Unknown. Because the person doesn't have a name. We remember that part, right? Then we can make another instance of this object. Person. Noob2. He's going to be a new person. And his name is going to be Bob. And his ID is going to be 100. And now we're running the other constructor. So if I print it out, the other one, noob2, get name. So now it's going to print out unknown and it's going to print out Bob. Unknown and Bob. Because we set Bob's name here. Just kind of reviewing again just to make sure we're all on the same page. I'm going to leave this one alone. We'll put that back out on the website eventually. So what happens now if we make person abstract? Abstract. Now I'm going to save it. And then over in main, immediately I got an error message, and I put my mouse over it, and it says, can't instantiate the type person. Because it's an abstract. So I can't make an instance of person. I could never make an instance of person if person is abstract. The difference now is I put the word abstract in there. The only reason why I'd want to put abstract in there is if I wanted to print out something, or if I wanted to do something from an inherited class that would overwrite the person behavior. Then I would create a method that was abstract. And then if I were to extend a class on top of person, which is what I'm going to need to do, then I can implement that method. And I get all these other methods as well. So for example, I'm going to stick it up at the top here. I'm going to say public abstract I'm going to call this one so let's just make it string. No, I'm going to make it void. Public abstract void method that's going to say print greeting. Let's see, print greeting, abstract modifier, remove method body. Abstract public. Abstract. Now I have to remember my syntax here. Where does abstract go? Abstract. Remove. Oh, that's because I have a method body. Okay. Hello, Barb. Okay. It's not implemented. It's not implemented because it's abstract. I tried to put a method body in there. The method body, this is the method body, by the way. If I have a method body, it means I'm implementing it. Okay, so those people that know C++, and if you remember the .h and the .c++ file, and then in the .h file, you put what's called a method prototype, or you put in a function prototype. And sometimes you did this with C. If you know C, you put a function prototype. What it is just a declaration of some function or some method that's going to exist, but it's not implemented. Instead, it's abstract. So you got two choices. If you leave this word abstract out, and here, let's just go public. Public void print greeting. There's an implementation in here. Just like these other methods down here have like the string get name. They have an opening and closing bracket, and it's implementing something, and it's doing something. If I want to pull it out, and I do this to it, I'm going to get the opposite message. It's going to tell me make it abstract. Change person print greeting to abstract. And if I do that, it puts the abstract word in there. Abstract means it's not implemented. So actually, I'm going to put in here greet, because that's too, I'm not going to remember the name of that method. So I'm going to put greet in here. Generally, an abstract class has at least one abstract method. If you have one abstract method in the class, the whole class has to be abstract. So if I come up here and I try to make this one, now I try to make this one non-abstract, it's going to tell me up here, it's going to say that the type person must be abstract class to define abstract methods. So it's a one-in-one. So what makes the class abstract is the fact that it has an abstract method inside of it. So to make the class abstract, you just put the keyword up here, abstract. Abstract goes before class, just like abstract goes before the data type here. So it's public abstract void. Void means it's not going to return anything. Greeting. So if I were to make a class on top of this class, extend a class from person, and I'm going to make student in a few minutes here. Out here in main, I can make some instances of students, as long as student implements the abstract method. If student doesn't implement the abstract method, then student has to be abstract, yeah? It's aired out because I can't make an instance of person because I changed person and I made it abstract. You can't make an instance of an abstract class. We're going to correct it right now. I'm going to make a student from a person, and then I'm going to make and make an instance of student instead. So we make the base classes abstract to sort of build the foundation of the functionality. And we want to have a greet message in there, but we don't want to implement the greet message because this person's going to say, person can't greet anybody, but a student can say, hi, I'm a student. And an instructor is going to say, hi, I'm an instructor. And they're both going to extend this abstract class. Just like the dinosaurs got extended from Dino, but because we put this unimplemented method in here, we have to make it abstract. So that's really the whole concept right there, actually. Abstract just means there's something in there that's not implemented yet, and we're going to reserve it. We don't want you to make an instance of person. It restricts you so you can't make an instance of person. So let's go ahead and fix the problem now. I'm going to go into File. I'm going to go up to New. I'm going to create another class now. And the class I'm going to call is going to be called Student. It's not going to be an abstract class, but it's going to be inherited. So the super class here, I can hit the browse button. Actually, I could just write in here person. I think I'm just going to write person in here. If I write person in here, I can actually change it in a few minutes. If I don't write person in here, I can just create it and then extend person. This will automatically put the syntax in for me. So I want it to be public. This one's student. It's going to extend person. And if I click the finish button, now I see class student extends person. And immediately I see this little error message that comes up. And I put my mouse over the error message and it says, well, you have to add the unimplemented method. You can't not implement an abstract method. You have to implement it. So if I were to do that, then I'd do this. And then if I take away the auto stuff, I'd see what I was going to do anyway in a few minutes. And you don't have to put override in there either. It just suppresses a warning that you are overriding it, which is stupid. So really what this is doing is it's adding the implementation for greets in person. If I don't want to put this in here, let me take this out for a second. If I say I want to delay it again, I don't want to implement greet. Instead, if I do this, then it says make student abstract. All of a sudden now I have another abstract class. I'm not solving the problem, just delaying the implementation until later. Why do I want to do that? Well, I can have an abstract class built in an abstract class built in an abstract class. And separate out all the functionality if I want to. Why people do that, I'm not quite sure. It depends on what you're doing. It depends on whether or not you want to have someone decide something later on. So JFrame, as an example, is an abstract class. You extend it. You can't make, well, there's two versions of it. There's an abstract version and there's a non-abstract. The abstract version of it wants you to set all of the window parameters. You have to set the title and the size and the opening and the closing operation. You got to do everything. If you don't do everything, it's going to complain. Just like this one. So if I do this one and I come back here and I do the unimplemented method, I'm going to take out the override. But really what we're doing is we're creating, and this is a polymorphic method because this is going to be overloading. It's actually overwriting. It's not overloading. Because this one here was never written. It's abstract. So the student is going to be just like a person, but in the method here, it's just going to print out greet. So I'm going to say system out dot print line. Hello, I'm a student. Named. And let's put the student's name in here too. This dot name. Oh, no, how about this? How about get name? How about, no, actually this dot name works. This dot name works just fine. Let's get the name. So I'm running a get name. I could actually, because student is a person, I could actually return the name. This is part of the same object. I could actually, well, there's a half a dozen or another reasons is why you'd want to do one or the other. But if I ran a this.getName on this object, I'm running the getName method. Well, the getName method is just going to return the name. Get the name is going to return the name. Well, I want to just print out my name. I could just print out this.name. So it's more common. Is it more common? I don't know. I could see it one way or the other. To get if I had conditions on here, for example, this one is private. If I made this one protected, then I could get it. See, because it's private. Actually, let me. Well, it's going to produce an error if I actually try to run this, because this name is private. It's only accessible inside of the class object that created it. If I make this protected, don't do this. But if I made this protected, then it's private in here. Excuse me. It's public in here. As well as, well, it's private. It's protected means it's accessible by any class that's inheriting it, but it's still private to the main programmer or main program. So in here, I could put name in here, but that's actually kind of a bad design. It's a bad design because it's not very protective. You want to make sure your data is protected inside of your objects that own the data. So that I can't, because theoretically I can change name in here. In fact, I can say this. I can go this.name is equal to Mary. And now I've just changed this object's name inside a person, but really the name belongs to person. So if I make this private, I'm going to get some error messages out over here if I save this actually. I should get error messages, and I do. It's going to tell me that the field person name is not visible. It's private. So if I make it protected, then I can see it inside a student. I don't necessarily want to. I think I want to leave that one alone. If so, then I'm going to use the public member function, which is really getName, this.getName, to actually get the name back and print it to the screen. I have the unimplemented method. It's right here. I think I have to save this to get rid of the error. Okay. Alright, so my person is now a student. So now I can go back to the main code and actually just make a student here. And you're going to go, well, you just made a person a student. And remove argument to match students. Okay. Create a constructor students. I didn't put a constructor in students. So let's put a constructor inside of students. So inside a student, well, I shouldn't have pressed that, but I did. I pressed on the auto generate. Let me take this out actually. This one works because I have a default. I don't have a constructor. I'm using the default constructor, and we get the default constructor automatically. I should have put constructors inside of student to create a student. Let's add the data, and we'll make student here. Student has a teacher ID and a teacher name. Wow. Student has at most one teacher. Teacher ID and teacher name. Okay. Inside of a student. Okay. Going with the flow here. So let's say private string teacher name and teacher ID. Private string teacher ID. Student. Why don't we give him a grade to grade level? Private integer grade level. So I implemented the method here that we had before, and let's make some constructors now to construct these guys here. Yeah. Teacher ID what? Oh, you're right. Let's go into right. That's Good point. I think I made the person ID. It's, yeah. Teacher ID. And we're going to actually borrow teacher IDs from teacher IDs that exist into the system. So I'm going to leave that unimplemented right now because I don't feel like doing that today. But grade level, put integer grade level, teacher name. So let's go ahead and make some constructors. So I'm going to back up to source and I'm going to implement constructors using the fields. But I also want to generate constructors from the superclass because remember I'm inheriting on top of person. So I'm clicking the superclass one. And so I have these two here that say person, and then I have person with a name and an integer. And I'm going to press OK on this one, and I'm going to see now that I have student. And student here is the default constructor. That's going to call the super default constructor, which is really person. And then in student, I can take student name and ID, and I'm passing name and ID back to super. So this is almost as if you were to put the word person in here, because super is person. So super is sort of a generic, in fact, if you put your mouse over it, it says person. Person.person. So it's actually running the person's constructor that sets everything for you. And this one's running the default constructor. And this is the person. So this is person default constructor. And then this one here is person other constructor that runs everything. This message should be gone by now. It's okay, it is gone. Okay, good. Let's just save it and the message will go away. It's not gone yet. Remove argument to match students. That's because I didn't create one in students. Yes, I did. Students. That's because I'm doing. Let's do it this way. Student. Do we not have a student one that does Bob and not ID? Student. String name. That looks like a constructor to me. Change constructor student, add parameter student. We have that in there. Create constructor student. We have that. Integer. It's the same one. I just put it in there. Maybe I need to save it. Let me take this out. I don't want two of the same. Oh, I just saved it. Huh? I think it's because I didn't save it. Yeah. I mean, and then when I hit the auto button to do it automatically, just duplicated what we just did. So I'm like, wait a minute now. All right, so person is a student. So you can cast, this is an interesting kind of thing here. So person noob is equal to new student. I can create an abstract person by creating an object of a inherited non-abstract object that is inside of a person. So if I wanted to actually create a person, I'd have to create a student and assign them to a person. But I don't necessarily need to do that, so I'm going to actually just put in student here. So student noob is equal to new student. Student noob 2 is equal to student Bob. Well, this is the same one, and I'm going to get the same results as I had before, unknown and Bob. Except for now it works, because person's now abstract and has this greet, and student has this method that says, hello, I'm a student. So if I ran greet for these guys, let's see. Let's just do new greet. I believe that is correct. Yep, let's see. Greet. G-R-E-E-T. G-R-E-E-T. What, noob is a noob. It's a student. Save it. Void. It doesn't do anything. It has to return something. We don't actually have to do that. We can just do this. Because it doesn't return anything, I can't print out anything from it. It would actually print out the word void. So what I did here is I made this a void function, and it prints out something. It doesn't actually return anything. If I'm not returning anything, it's impossible for me to system out what I'm returning, which is why that didn't work. If I wanted to do it properly, I could return a string instead of making it void. So let's go ahead and run it. Now it's going to say I'm a student. Hello, I'm a student, name unknown. So now the concept is I can make an instructor, or what's the other one going to be? Teacher. Let's go ahead and make a teacher now. Well, let's make an employee. Well, employee is an instructor, so let's go back to my hierarchy here. I got a person, I'm going to make an employee next, because I made a student, so I'm going to make the employee. And I'm going to override again, same thing I did already with the person and the student. Now I'm going to make an employee. So I'm going to go back up here and go File, New, Class, and this one's going to be called Employee. And this one is also going to be from person. So Employee is also a superclass person. I'm going to press OK. And over here it's going to tell me to add the unimplemented method. Sure, why not? So I also have to add the greet to every single one of my classes that I inherit from person. So what is the abstract method then really doing for me? It's providing some level of consistency between all of the different objects that I'm creating of the same. They all come from the same hierarchy. If they're all coming from person, then they all have this method in them called greets. So I'm going to just cut and paste this out of here and change it. And once I implement it, it's no longer abstract. But the idea being, if it's a employee, if it's a person, then I can't greet. But if it's a student, I can greet it. If it's an employee, I can greet it. So this one's going to say, I'm an employee named, I think I'll change the other one to named too. I'm a student named so let's see, if I save it, the error should go away, and it does. Excellent. So now I can make, out here in main, I can make an employee, and I can pretty much do the same thing. So I'll just do it down here. Employee E1 is equal to new employee. Make this one Ed, because he's E1, and his employee number is going to be 200. And then I'm going to have the same problem as I did before. I didn't put in the constructors, so I have to add the constructors so that I can construct. And I still haven't done anything in particular with the student yet, so I'm going to do the same thing with the, I'll put them above. I'm not going to add anything to employee this time. I'm just going to make the constructor so I can construct an object. So edit, oops, source, excuse me. Constructors from superclass. Person looks pretty good. So now I can make an employee. And then I can make an employee with the name and the ID. There we go. I'm just getting rid of the auto messages. So I'm borrowing all this behavior from person, and I really haven't done anything but implement this unimplemented method greet. So if I run it now, I should get, oops, what did I do? Main. Haven't done anything with Ed yet. So I have to copy this line here. Oops, let's just copy these guys. And this is going to be E1, and then I'm going to do the E1 here. Perfect. Well, actually, we don't need to do that. We just need to print it out. probably clean up this one too. It just needs to greet. We don't even need this noob either. I think I need to. Noob. There we go. So I'm making one of each now. So I have a student noob and employee E1, Ed, Bob, and Ed and Bob are going to greet us. They're going to basically tell us who they are and what their names are. So if I run it, hello, I'm a student named Bob, and I'm an employee named Ed. And they're both people. So if I have in fact, what I'm doing, especially in employees, I didn't give employee any data members at all. It has no new functionality. I'm just extending from the abstract method. So in a lot of cases, that's what we're doing when we're building classes on top of abstract classes. Some of it is not implemented and some of it is implemented, and we can use the pre-existing functionality. So, and we're doing this because we don't necessarily want to decide at this point who the person is. If we were a shape, as an example, if we were an abstract shape, we wouldn't be able to do an area. However, if we were a triangle or we were a square or a rectangle, then we might have a different area implementation. So if we had an abstract shape that had length and width, and it had all of the different parameters of the shape that was defined in there, and it had a method that was abstract that said, get area. And then we built a rectangle on top of shape, we extended a triangle on top of shape, we could implement the get areas, and that would be appropriate for the different shapes that we were creating. So abstraction and abstract methods and abstract classes are put into place so that you don't put in any weird behavior that doesn't apply towards the object. So you can only put in stuff for the object that's actually appropriate for the object, and then you're forced to implement certain things. So whatever shape I make on top of shape, I'm forced, not forced, yeah, I am forced, because the program's not going to compile unless I implement that abstract method. So, all right. This is a good stopping point, actually, for today, I believe. So let's see what time it is, actually. Yeah, it's a good stopping point. So I'm going to end this part, archive this, stick it out on the website for next time. And then we'll start with this one, and then we'll really build the rest of the assignment out, actually. So let me stop this capture.